All right, we're looking at 2013. So this is I'll go 2013 Calc NCEA external exam, and this is question 1e. Here it just says E, so you have to take my word for it. But it's NCEA external question 1e, and it says g of x is equal to negative x cubed 3x plus 2 for what values of x is g a decreasing function? And you must show your use of calculus. You must show use of calculus in your working, blah, blah. All right, so let's go ahead and do that. So I'm going to do this on a separate sheet, actually. So I've got a bit more room to work around. So first thing I'm going to do is restate the question. So I'll just put question 1e 2013. So I'll put it so you can see it as well. I'll restate the question. That's Calc external NCEA 2. Okay. Excuse me. So we've got g of x is equal to negative x cubed plus 3x plus 2. So the first thing I want to do is to work out, well, if we're going to find out where it's decreasing, it's going to be decreasing or increasing on either side of whichever and wherever the turning points are. So let's find the turning point. So that's step one, find turning points. So to do that, I'm going to find the gradient function of this. The gradient function will be based around g prime of x. So I'm going to differentiate this. This is going to be negative 3x squared plus 3. And of course, the gradient, the turning point exists where the gradient is 0. So I can just make this thing here 0. 0 is equal to, and I'm going to factorize this. Let's go, what's common to both of these? Well, let's go negative 3 is common. So negative 3, what times negative 3 makes negative 3x squared? Well, it's just going to be x squared. And what times negative 3 makes positive 3? Well, that would be negative 1. So there's my factorization of this. Let's check it. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 1 is positive 3. That works well. So I'm going to divide both sides by 3, or divide both sides by negative 3. Here we go. Divide by negative 3. So negative 3 divided by negative 3. This is going to equal 0 is equal to, and I've got x squared minus 1. So I can just factorize that. Here we go. So I've got 0 is equal to x plus 1, x minus 1. It's just the difference of two squares. So we can say that either x equals 1 or x equals negative 1. So, and normally, by the way, you put this in the reverse order. I'm going to do it right now. Next is negative 1 and positive 1. So they are the 2 points where the turning points exist. So if we were going to draw that up, and I'll just try and roughly draw it now, just very, very roughly. And the reason we want to roughly know where these are is because we know that it's increasing or decreasing on either side of those points. So here is my negative 1. And it's my negative 1 point, and here is my positive 1 point. There it is. So this thing is going to be, first of all, it's a negative cubic. We know it's negative because it's got a negative in front of the x cube. So it's going to be something, and we also know that the intercept is 2. The y-intercept is 2. So here's my 2 point. So it's going to do something. It's going to be a negative shape. So it's going to be something like this. It's going to go through 2, it's going to go around, and it's going to go down like this. This point here is going to be, therefore, the maximum point. The point to the right for a negative cubic is to the right is the maximum, and the point on the left is the minimum. Now, the minimum could be anywhere. The maximum could be anywhere. The minimum could be down here, up through 2, could be touching the x-axis through 2, could be just a little shallow bit like this, yeah? We don't know, but we do know that the turning point is negative 1. And we do know that everything to the left of the turning point will be decreasing. So I could put here negative cubic, therefore I could say x vowels to left of left, I'll put left hand turning point will be decreasing. Yeah, and you could say that on the other side here, similarly, and I won't bother writing this, but you can write this. x values to right of the right-hand turning point will be also decreasing. So they're decreasing here. In other words, the gradients here. So let's say where this was here, the gradient here, the gradient here, the gradient here. These gradients are all negative. The moment it gets to 0, the gradient will be 0. Sorry, turning point, the gradient is 0. At which point it starts to become positive again. Gradient is 0 at the maximum, but then starts again becoming negative again. Yeah. So that would be a statement you could use, but I want to actually prove this. So we want to check, so I'm going to go test, oops, sorry, I'm keep kicking the camera here. So I'm just going to so I'm not going to do that, sorry. So I'm going to have, here we go. So I'm just going to say here, test point to left of left hand turning point. Here we go. So -1, I want a point to the left of that. I'm going to choose -2. Yeah. So I'm going to check -2 to find out what the gradient will be. So I'm going to take g of x. Here it is. G prime x is equal to -3x squared plus 3. I'm going to put into here -2. We know if we put in -1, this will be 0. But let's put in -2. So we're going to find out whatever value this is here. And what we're looking for here is a negative value. If this value is negative, then it's decreasing. If this value here is positive, then it's increasing. So I'm not particularly concerned with the value. I just want to know if it's positive or negative. So let's have a look. So I'm going to go -3 times, and I've chosen -2. I'm going to square it and add 3. So what do I get here? Well, 2 squared is 4. -2 squared is 4. -3 times 4 is -12 plus 3. And so what I've got is a -9. So we can say, so that is m. Yeah, that's the m value. Gradient is therefore negative. Well, gradient is therefore negative. And let's check on the other side as well. In fact, we could check in the middle if you want. We could check at, say, we've got -1. We could check at 0, but we know it's not going to be. And we could check, let's say, check to the right of 1. Yeah. So let's check 2. So, and again, 2 here, we're expecting it to be negative. Yeah. So I'm going to here. So I'll put that's -2. I'm going to put test point to right of right hand turning point, and I put 2, and g of x is equal to, and I'm going to make this -3 times 2 squared plus 2, and the m value here will be, in this case, again, -9. So a grade therefore is negative. So what we found out here is the range of values now. In other words, we know that this side here, to the left of that turning point, everything is going to be negative. To the right of this turning point, everything is going to be negative. And in between is all positive. All right, so let's write that out so we can say, and I think probably the language they just want to say, just use some sort of inequality here. And I think just basically saying that x, yeah, I'll just write it like this. X will be, hang on, let's have a look here. So x has to be less than -1, or x has to be greater than 1 for decreasing x values. And that is what I would put, yeah? So it says for what values is x decreasing, and that's the final bit you want to put in there. So you must have that statement in there, and if you do, that's the bit they're wanting. Now, I messed around a lot with all this stuff, and I'm just really teasing it out, thinking it through the way which I would think it through. Hopefully that makes sense, though. Have a read through there anyway, and hopefully that would work for you. Now, that is an excellence question, by the way, so a little tiny bit of writing's involved, but you do want to have clarifying statements there as well.